Week 11, problem 11. Assume a transparent rod of diameter d equals 6 micrometers has an index of refraction of 1.2. Determine the maximum angle theta for which the light rays incident on the rod at the end of the rod in the figure below are subject to total internal reflection along the walls of the rod. Your answer defines the size of the cone of acceptance for the rod. Okay, this isn't too bad. We can do this. So, we'll start by drawing a picture. So I'm going to draw it like this. So, make the light a different color, which only seems reasonable. So light comes in at some angle, this angle to be precise. This will be theta 1. So it then bends this way. Nah, that's too dramatic. I'm going to say it like this. So in the picture it doesn't look like it's bending, but it's bending. So then it comes up here, hits again. This guy right here will be theta 3, and then this will be theta 4. Nope, this right here will be theta 4. Alright, so the concept here then is, they said, let's see here, subject to total internal reflection, right here, internal reflection along the walls of the rod. Which means right here, ooh, didn't mean to move that guy. No, did it again. This guy, theta 4, is going to be 90 degrees along the wall of the rod. Okay, got it. So, we'll do Snell's law again. Sine theta 1 over velocity 1 equals sine theta 2 over velocity 2. So the strategy I'm going to have with this problem is I'm just going to write down as much info as I have, and then hopefully it'll make sense at the end. So no real grand strategy in life here. Basically walking into the forest, and hopefully I'll just find the cottage. Cottage made out of gingerbread. I'd say that's probably a terrible plan. You don't want to find that cottage. It's, yeah, trust me on this one. Okay, so now we'll start writing out the stuff that we know. So we know theta 2 and theta 3 are kind of part of the same triangle. So I'm going to say that theta 2 plus theta 3 equals 90. You can also say that 90 plus theta 2 plus theta 3 equals 180, but you rearrange things and you get this. Let's see here. Then I'll rearrange that a little bit more and say theta 3 equals, no, maybe, possibly. Nope, I'm going to do it a little bit differently. I'm going to say theta 2 equals 90 minus theta 3. I could be backwards if I have to redo it later. That's not a big deal. Not a big deal. Alright, then I know that theta 4 equals 90 degrees. Alright, so now I'll start coming over here, start simplifying things. Get my trusty blue. So, sine of 90, we know this guy right here is, what is that? That's 1. Sine of 90 is 1. So, make a little arrow. Sine of theta 3 equals V3 over V4. Seems reasonable. Is that true? Yeah, probably totally true. So then we know that theta 3 equals arcsine of, now, let's see, they say air? I'm pretty sure somewhere mentioned air. Maybe. I'm going to say that over here is n equals 1. Index of refraction equals 1 on the outside. So, that means that V3, which is the velocity inside the glass, the cone, the rod, not the cone, not important, you understand, is the speed of light divided by 1.2. And then V4 will equal 1. So right in here then, oh, not 1, C. So then we have c divided by 1.2 divided by c, and the c's will cancel out. So then we're going to be taking the arc sine of 1.2. Which makes sense, because when you take the arc sine of something, it should be less than 1. Yes, I think that's totally true. Probably totally true. Okay. So this gives us theta 3. So now, if we come over here, we're going to we need to find, what are we finding? I just started working and never actually, yes, we want theta 1. We want that guy right there. Next time you walk randomly into the forest, you should probably pick out a goal first. So, theta 1. Alright, so I'm going to say the sine of theta 1 equals v1, which in this case, let's see, v1 started on the outside, so it's just going to be c, divided by v2. v2 is inside the glass, so it's going to be c divided by 1.2. And then we're going to be times the sine of theta 2. So theta 2 is 90 minus theta 3. So I'm going to do, I should probably just figure that out right now. Yes, I'm totally going to do that. That way I don't have to keep carrying everything forward. So let's figure this out. 90 minus arc sine of 1.12. I'm going to do it this way. Arc sine of 1 divided by 1.2. I think that's what I wanted. Yes. So theta 3 is 56.44, which is similar to 56.4. Okay? So now I'm going to do 90 minus 60.4. 90 minus 56.44. And we have 33.56. 33.56 is theta 2. Okay. So now we're going back to this equation again. So now we have these guys cancel. So when we do this, we have c over 1 divided by c over 1.2. And what happens is when you divide by fractions, you multiply by the reciprocal, so we actually have 1.2. 1.2 sine of 33.56. And that's where we determine that 33.56 degrees is theta 2. Okay, follow me? Excellent. Excellent. So now we got theta 1 will be the arc sine of 1.2 times the sine of 33.56 degrees. Okay, I think that's right. So maybe I can just click on this guy. Pops up, maybe. Does that work? Oh, it's not that complicated, Wolfram. You don't have to do this much thinking. Alright, so we'll do sine of, multiply this by 1.2, and take the arc sine of, and then this should give us the answer. I wonder if it realizes 33.56 degrees. I should probably mention that's degrees, just in case. I think it said it wasn't. Alright. Arc sine 1.33.56. Yeah. Does that seem reasonable? Okay. Actually, I'm going to go over real quick, make sure I didn't mess up the arc sine of the other guy. So we wanted to find the arc sine of 1.2. 1 divided by 1.2, that gives us 0.83. Arc sine of 0.83. Sorry, I'm just trying to question myself here. Make sure I didn't go crazy. 56.1. Okay, so we totally did the theta 3 right. All right, back on track. All right, so now we have arc sine of 1.2, sine of 33.56, and that gives us 41.56. Go over here. Equals, make sure, yeah, seems reasonable. Equals 41.56 degrees. Check one more time, 41.56. And this is arc sine 1.2 sine 33.56. Yes. So this tells us that theta 1 is 41.56 degrees. 41? 41. 41.56 degrees. And this guy right here, completely useless. Didn't use him at all. Yeah, alright. I think that seems reasonable. That probably just tells us that it's a thin rod. Alright, and that is how you do problem 11.